relationship between classes and object-oriented programming. In this presentation, we will explore the importance of the relationship between classes in object-oriented programming and its application in software development. Join us on this journey of discovery. Introduction to topic. Before we dive into details, it's crucial to understand what class relationships are in object-oriented programming. We will learn how classes interact with each other and how these interactions form the basis of robust and flexible software design. Examples of relationships between classes in object-oriented programming. Inheritance. We will explore how a class can inherit properties and behaviors from another class using a practical example that demonstrates how the inherent relationships is used to build a class inheritance. Composition. We will discover how classes can be composed other class, creating a part whole relationship that allows us to build more complex and reusable structures. Aggregation. We will show how classes can be related in a whole part way, allowing the creation of flexible and dynamic association between different objects. Types of relationship in object-oriented programming. 1. Inheritance allows you to reuse and extend the functionality of a base class. 2. Composition allows you to build more complex structures by combining multiple classes. 3. Aggregation allows the creation of association between objects. Advantages of using relationships between classes in object-oriented programming. Code rules. Relationships between classes allow us to take advantage of existing functionality instead of reinventing the wheel. Flexibility and maintainability. Well-designed relationships provide more flexible, maintainable code as a requirement evolve. Organization and modularity. Clear relationship between classes help structure the code and encourage great modularity and cohesion. Considerations when designing relationships between classes. 1. Coupling. About excessive coupling to maintain flexibility and reusability. 2. Cohesion. Ensure that each class has a clear and well-defined responsibility. 3. Abstraction. Use interfaces and abstract classes to facilitate extension and change. Conclusions and recommendations. 1. Planning. For good practice in the relationship between classes, carefully plan the structures and interactions of the classes before you start coding. 2. Refactoring. Perform regular refactoring to improve relationship between classes and maintain clean and flexible code. 3. Continuous learning. Stay up to date with best practice and design patterns in object-oriented programming to optimize your design of relationship between classes. Thank you for watching.